So in our last video, I gave you the example of the American Twiddle Company, where the amounts that people make varied quite a bit. The president and the vice president made a lot more than the other workers, but the mean turned out to be $316,000. Now, if we took all that money that got paid out to all those people and redistributed that same amount so that each person got the same amount as everybody else, then that same amount that everybody would get would be $316,000. So that's one way you can think of the mean. The mean tells you how much each person would get if the same total amount of money were redistributed so that everyone got the same amount. And as we've seen, if you have some extreme values that are much higher or much lower than the rest, that can really make a difference to what the mean is. And so sometimes what's reported instead of the mean is the median. And if you have to have an abbreviation or a symbol for that, you can abbreviate it MD. But that's not as common as abbreviating the mean with the symbol X bar or mu. But the median is the value that falls in the middle when all the values are arranged in order, like from lowest to highest. So if you know what the median is, then you know that half the values are above the median and half the values are below the median. If you knew what the median salary was, then at least you'd know that, oh, half the people are making more than that, and half the people are making less than that. So often the median is reported for things like salaries or wages, or how much houses cost. There might be a few houses in an area that are especially expensive and cost way more than others, but if you know what the median is, then you just know, that's a nice central amount. Some are more than that, some are less than that. So I read somewhere that of Americans who have savings accounts, the median savings account balance is $5,200. So half the savings accounts have more than that, half have less than that. But the average or mean balance is $33,766.49. So some of the people who have more than this have a lot more than this. So here's how you find the median of a set of data. Arrange the data in order. If there are an odd number of values, then the median is the one in the middle. Like if there were 5 values, the median would be the third one. If there are an even number of values, then the halfway point doesn't fall exactly on one of those values. Instead, it falls right in between two of them. So in that case, the median would be the number halfway between those middle two values. And if you can't just see what that is, you can add them together and divide by 2. So some quick examples. What's the median of 13, 15, 16, 19, 23? Those 5 numbers there? 16. That's the one in the middle. There are 2 of the numbers that are less than 16, and 2 of the numbers are greater than 16. What about this set of numbers? What's the median of this set? If you said 40, you fell into my trap. It is not 40. None of the numbers are below 40. All the other numbers are above 40. So 40 is not the median. And what's going on here is these are not arranged in order. If they were arranged in order, it would look like this. And the number in the middle would be 56. So there are the same amount of data values that are less than 56 as there are greater than 56. 56 is the median there. And what about this set of numbers? This time they are arranged in order. They are already arranged from lowest to highest, but there are 6 of them. There's an even number of values. So the median isn't one of these numbers. Instead, it's what's right in the middle here, separating the bottom three from the top three. So the median is going to be halfway between 127 and 141. So we can figure out what that would be by adding together 127 plus 141, which is 268, and then dividing by 2. So it's like we're averaging those two numbers together to find what's halfway between them. That turns out to be 134. So here the median for this set of numbers is 134. We have the same number of values that are bigger than 134 as we do smaller than 134. So going back to those examples we were looking at earlier, Class A and Class B, this is another place where if you think you know how to do this, you can pause the video and see if you can come up with the answer yourself, and then unpause it and see if you were right. Okay, so here's the answer. Class A, arranged in order, looks like this. There are 12 numbers, an even number of values. So the middle two would be the 80 and the 81. And so the median would be halfway between 80 and 81, which would be 80.5. For Class B, the median would be halfway between 83 and 84, so 83.5. Notice there are 5 of these numbers that are less than 83.5, and there are 5 of them that are greater than 83.5. And then the mode. The mode is the most common data value, the one with the highest frequency. And it is possible for a data set to have more than one mode, if there's more than one number that's tied for most common. And it's possible for a data set to have no mode. So if all the numbers are different, nothing appears more than once, then there is no mode. So in my example of the American Twiddle Company, what was the most common salary that more people made than any other dollar amount? $20,000. 8 people made $20,000. Only one person made $2 million. Only one person made $1 million. And going back to our Class A and Class B, again, if you want to pause the video and think about it, here's the answer. For Class A, notice there are 2 73s and only one of anything else. So the most common score was 73. That's the mode. And for Class B, the mode is 83. 2 people got an 83, so that was the most common score. Now, there are ways of using special built-in functions on certain models of calculators, or certain calculator apps or computer software that will take a bunch of numbers and just tell you what the mean is, or what the median is, or what some of the other things that we're going to talk about are. And for just the mean and the median, there's not a real big advantage to using those, because you still have to put in all the numbers. You still have to enter all the numbers into the calculator or the computer, and it's not all that much harder just to add them together and divide by how many there are. But I will be showing you how some of those things work, and they do come in handy for something like the standard deviation, which we'll talk about in the next section. So coming up, like at the end of this series of videos somewhere, I'll show you how some of those special calculator functions or apps work to give you the mode and the median and some things like that of a list of numbers that you put in. There's one more measure of central tendency that's not used nearly as often. It's not all that informative, but you might hear about it sometime, and that is the mid-range. So the mid-range of a bunch of numbers is just if you take the highest and lowest numbers and add them together and divide by 2. So that gives you a number that's numerically halfway between the biggest and smallest value. It's not the same as the median. The median is the number where half of the numbers are above the median and half of the numbers are below the median. So in one of the examples that we were looking at earlier, this was class A, this was class B, where the highest score was 91 and the lowest score was 35. And it doesn't matter what the others were. For the mid-range, we just take the highest and the lowest, add them together, and divide by 2, and we get 63. So 63 is halfway between the highest and lowest score. Now, everybody except that lowest score did do way better than 63. So knowing that that's the mid-range doesn't necessarily tell you all that much, but that's what that is. So here's an example to review what we've talked about so far in this section. At company Y, the yearly earnings of the various people who work there are listed here. So we got one person who earns $100,000 a year, one person who earned $65,000, $32,000, $28,000, $12,000, $18,000, $22,000, $14,000, and $33,000. What are the mean, the median, the mode, and the mid-range? So this is a place where you could pause the video and try to answer those yourself. So I'll let you do that if you want to try, and then you can unpause and I will tell you the answers. Okay, if you've tried to find the answers to these, they are, the mean is 36,000. There are 9 numbers there, so if you add all 9 numbers together, they add up to 324,000, and then you divide that by 9, and you come up with 36,000. The median is 28,000. If you arrange these in order from lowest to highest, 12, 14, 18, 22, 28, 32, 33, 65, 100. The one that's right in the middle is 28,000. The mode? Well, there is no mode because none of the numbers appears more than once. And the mid-range is 56,000. You take the highest and the lowest, add them together and divide by 2. Now later on I will show you how to use special built-in calculator functions or Excel functions or things like that to find at least some of these things, but I'll put that in a separate video. Speaking of separate videos, I'm going to end this one right here, but there's still some things we need to talk about. We need to talk about weighted means. We need to talk about means of grouped frequency distributions. So I'll come back and talk about that in part 3 of this video.